Thank you again for giving me this opportunity to present and share this issue in front of you. You will see these are hot topics, and this fits very well in this session about hot topics in pediatric anesthesia. Again, I have no conflict of interest in relation to this presentation, and none of the drugs I am discussing are off-label use. So the 4 drugs I'm going to share with you today: suxamethonium, bupivacaine, paracetamol, or Acetaminophen, I don't know in Italy how is it called, and codeine. And I will touch on tramadol. Suxamethonium was, the synthesis was done in 1949. You know that it acts on the neuromuscular junction, and it leads to random muscle contractions and inactivity with the neuromuscular junction for 4 or 5 minutes until there's a drug broken by local pseudocholinesterase. Now, the problem with this suxamethonium is that there are many side effects. And the side effects are due to actually its mechanism of action. And beside the allergy, the prolonged apnea because of deficit in pseudocholinesterase, fasciculations and the myalgias that can occur, bradycardia, particularly if you inject the second dose, I would like to talk to you about hyperkalemia. So what happens with the potassium increase when you give suxamethonium? What you need to know, it's unpredictable. While you expect a small increase systematically when you give suxamethonium, less than 0.5 millimole per liter, but this can go to over 1 millimole per liter, even increase higher than this, particularly if you have either structural alteration of the muscular fiber, like in the presence of myopathies or rhabdomyolysis, or if you have an increase in postsynaptic acetylcholine receptors at the neuromuscular junction. And this is the case in the burn patient or prolonged immobilization or hemiplegia. So if you look at the cardiac arrest after suxamethonium, you see that the higher mortality occurs when you have rather in the presence of myopathy or rhabdomyolysis rather than when you have receptor regulation. But this is real. So there have been in the last few years, a decade, a big debate in the literature whether we should say goodbye to suxamethonium or is it still early and is still a place for suxamethonium. So why are we using suxamethonium? We're using it for rapid sequence induction. So if you compare it now with the new rocuronium that we use for rapid sequence induction, particularly that we have Sugamadex now available. So if you compare, and this is a meta-analysis, a recent meta-analysis comparing both drugs and looking for excellent intubation condition, and you see that suxamethonium is always better until 1.2 milligrams per kilo rocuronium, where there was no difference between the 2 drugs, although these are small studies, and there's a huge heterogeneity. If you look at acceptable intubation condition, you see that there is a similar condition if you just use acceptable. Now, if you look at the Cochrane systematic analysis, looking at a comparison between rocuronium and succinylcholine, in 2003, Cochrane suggested that if you use propofol during rapid sequence induction is better condition. In 2008, if you use propofol, again, it's good condition. And the recent one, if you use thiopentin with succinylcholine, it's better condition. So the problem, I tell you why it comes from. It comes from all these studies talk different languages. When you use rapid sequence induction, the true rapid sequence induction is when you give hypnotic and the myorelaxant, you wait 60 seconds and you intubate. But most of the studies do either modified rapid sequence induction or different timing of giving myorelaxant or priming with the myorelaxant, and this is all the heterogeneity of the drugs come from, and today we don't have enough data on this. The other thing that you need to know, now that we have also the monitoring of regional saturation, is that when you give when you compare suxamethonium with rocuronium for rapid sequence induction, it's interesting to know, and surprisingly, you have faster onset of decreased saturation with suxamethonium rather than when you use rocuronium. Why that? It's because of the fasciculation and increase in the metabolism and increase in the oxygen consumption. So, second drug I would like to talk to you about is bupivacaine. So you know that bupivacaine is part of the amide class of long-lasting local anesthetics. And this is, again, like oxygen, you have a dual nature. Analgesia effect, which is really good, and the toxicity. However, bupivacaine, there are three things I want to share with you. Besides its high neuro and cardiac toxicity, you have also some new studies showing up the immune-mediated reaction when you use bupivacaine, and also if you infiltrate locally, you have cell toxicity and proliferation. The first thing is the cardiac toxicity. Now, this is a very nice study. I'm just showing you, just to summarize it. It's talking about multiple correspondence analysis using different local anesthetic on this panel on the left and EKG parameters. And you can see that on the left side, the more it's on the left, the more toxic it is. Bupivacaine is the most toxic drug, followed by ropivacaine and levobupivacaine and lidocaine. And if you look also at the multiple correspondence analysis using the hemodynamic factors, parameters, again, the most toxic drug is bupivacaine. The new thing that is coming on the literature nowadays is the appearance of the immune-mediated reaction. And it seems to be independent of the dose. So if you do a continuous infusion that has been reported after 48 hours of continuous infusion up to 2 weeks, what happens is that appears cholestatic liver injury with more eosinophilia, both peripherally and in the biopsy eosinophilia in the liver. And, here we go. And, missed one slide. Anyway, and the other slide is that has been shown in some studies in adults, particularly if you infiltrate bupivacaine with the pain, back pain, you have some apoptosis appearing and proliferation, cell proliferation locally. Paracetamol. Paracetamol, you know this drug, you use it every day, everybody uses it. It's like a lollipop somehow. More than 600 drugs over the counter contains paracetamol. This is a big problem, and the global market is huge, is expected to be 1 billion in 2020. The problem is that there have been many warning about paracetamol. Many warning because many deaths have been reported because of liver poisoning. Just for example, in Canada, 4,500 patients every year are admitted for liver poisoning. The second thing, that is more and more evidence between association of paracetamol and the appearance of asthma and COPD. And now what is new is that paracetamol may be associated with some autism spectra and also problem with the attention deficit disorder and neurodevelopment. What it comes from? It comes from the NAPK. The NAPK is a toxic metabolite that is due to the 10% of paracetamol that is metabolized by the cytochrome P450, the allele 2E1. Normally, this NAPK is detoxified by the glutathione reductase. You know, I spoke to you about the reactive oxygen metabolites. You know that when you use high oxygen, you do screw up the glutathione reductase, excuse me about the term. So that will increase to the NAPK. So the NAPK is actually nasty because it is release sensory neuropeptides and leads to neurogenic inflammation that via the TRPA1 channel, which is the transport A channels that play a major role in the airways in physiology. This is just a study in mice showing that if you give paracetamol 15 milligrams per kilo twice, and it's similar to the dose you give in children, you have immigration of neutrophil elastase positive cells in the tracheal, epithelial, and subepithelial species. Just to show you the TRPA channels and the role of these channels in respiratory physiology, you should know that these channels act via the C fibers, and they can release neuropeptides responsible for cough, bronchoconstriction, and neurogenic inflammation, and airway hyperresponsiveness. And this is how it is due because of the passive smoking and the pollution. It goes through these TRPA1 channels. So what you should know clinically. The first study that highlighted the potential association with asthma and allergy was published in The Lancet from a huge study, the ESAC study, and they have demonstrated even if you adjust for sex, the region of the world, the language, the national income, etc., that there is association between the use of paracetamol in infancy and childhood and the occurrence of asthma at 6-7 years, eczema, and renal conjunctivitis. There have been a huge debate after this Lancet paper to see whether it's only a surrogate, it's an association, or the causality. And they looked again at all the studies, looking to see whether the use of the paracetamol in the presence of respiratory tract infections and correcting for this changes something. And you can see here that if you don't adjust for respiratory tract infection, you still have a higher association. However, if you adjust, there is increased tendency, but you see that the 95% confidence interval does cross 1, and therefore it's less evident. So this debate is still open at this stage. What is new today is that there are some new studies showing that paracetamol the use of paracetamol in pregnancy or the first 6 months in children may be associated with attention deficit disorder. And this study is very nice from Denmark. You know that in Denmark, when you are born, you have a number that follows you until you die. And you know the people they have a big database, even any prescription, they have it inside. So they looked at 64,000 children, and they looked at 7 years whether they have been diagnosed either in the hospital or they have been prescribed Ritalin against the ADHD, and you can see that was an association. Now, this is EPUB ahead coming from Spain, looking at 2,600 pregnant women receiving paracetamol, and again, they've seen a attention function in children at 5 years of age and autism spectrum symptoms. So what happens? Henrik Weiberg is working very much on rats and looking on paracetamol, and it seems that paracetamol, it does induce hormone disruptor and may influence fetal brain development. Now, a new study again is EPUB ahead. Now, this one is coming from Norway, where they're looking at 51,000 pregnancies and doing propensity scores between those women who received long-term paracetamol during pregnancy and or those who had short-term, and they demonstrated that long-term is associated in children with communication problems and delayed motor milestone attainment. So, is it useful in children? This meta-analysis in 2016 looking at paracetamol giving for pain procedures in infants, heel lands, or for pain after vaginal birth, or eye examination for prematurity or postoperative care, and they saw that the paucity and low quality of existing data do not provide sufficient evidence to establish the role of paracetamol in reducing the effects of pain procedures in neonates. What about adults? There's high quality evidence that paracetamol is ineffective for low pain, and there's high quality evidence that paracetamol increases the risk of having abnormal result in liver function tests. I did a huge research to try to take off the number needed to treat with the different analgesic, and you can see here the paracetamol, particularly the IV paracetamol. You see that use the paracetamol for acute postoperative pain has the highest number needed to treat when you compare it to non-steroid anti-inflammatory drugs, and this comes from 6 Cochrane analysis. Thank you. Meta-analysis. Let's go to codeine. I still have 6 minutes and 30. This is very stressing. So this is the last drug. Codeine, global demand all over the world. I know I just learned that you took it off in Italy, which is a good thing, but I have to talk to you about it because there's a new warning 3 weeks ago with tramadol, and it's a bit the same concept, and it's good to discuss it. Now, there's still, and this is in 2011, that 269 tons of codeine used all over the world, particularly in the UK and in India, and also in France. It's still going on in France. They still prescribe codeine. Now, the problem of codeine, the metabolism, it has to go through the nasty CYP2D6, cytochrome D6. And this is the nasty one, and that it has to, and this metabolite, codeine, has to be metabolized into morphine, that is the active metabolite. The problem is that there is a genetic the variability in this cytochrome P450 with 8% ultra-metabolizer and 36% poor metabolizer. And this is due to the polymorphic nature of codeine metabolism and tramadol metabolism. It's the same thing. With this gene encoding with the cytochrome P452D6, either you have poor metabolizer and they have little or no morphine, or you have ultra-rapid metabolizer and you have large amount of morphine, and this will lead to toxicity. And this has been associated with fatal toxicity, particularly to children where we gave codeine after tonsils, obstructive sleep apnea, or children with having myopathy, etc. And that led to guidelines from the American Society, American Academy of Pediatrics, guidelines all over the world from FDA warning. And you see that the guidelines was set in 2007, and this is the expected prescription of codeine. The summary of this is that the guidelines have limited impact on prescription behavior. And this is a real problem. So codeine is still prescribed. So is it something, what is new in this? Well, codeine is still prescribed, but some hospitals start to do a pharmacogenetic-based codeine prescribing. So this was published very recently, just before Christmas in St. Jude Hospital, where they do genotype in all children where they want to prescribe codeine, and you see that they discovered 7%, they have an algorithm. If you have ultra metabolizer, they have 7% of their population, they do not give codeine. If they have 1.4, they don't give. If you are normally, then they give codeine. So this is due to this. What you need to know that in 2013, there was a European Medicine Agency contraindicating codeine in all children of obstructive sleep apnea in the ultra-rapid metabolizer, children with neuromuscular disorder, and they've put only potential indication in children over 12 years if there's no effectiveness of ibuprofen. 15 of the 28 European countries has banned codeine in the sales. 20th of April 2017, there was a new warning of the FDA. What was new? A new contraindication to the tramadol label warning to all children younger than 18 years to treat pain after surgery to remove the tonsils or adenoids. This new warning put us in a difficult situation because we are now, I prescribe tramadol in adenotonsils, and now we have to review all our analgesia effect. And this is the same as codeine. That's why I think it was important to show you. This is just went out. And we are in trouble now because we don't know what to do. And you can see that it's going through the cytochrome P452D6, the same as codeine. Right. So why should we use codeine? It's actually, we should not use it because that's little evidence of effectiveness. And you can see here, these are the big circles, are big studies where they found some evidence. They are very small studies. And we look at this, if you look at the number needed to treat for at least 50% pain relief over 4-6 hours, you can see when you compare with in randomized controlled trial with placebo that the number needed to treat goes up to 18. You need to treat 18 patients to have a benefit 50% reduced pain in one patient. So there's no effectiveness. What I now what I wanted to show you in the last 2 minutes is the use of codeine in anti-cough syrup over the counter. And actually these numbers are for 2013. And Italy is among the 15 most important countries where you have full codeine consumption per million inhabitants. And you may know that 5 kilo of full codeine are prescribed in Italy per million for the cough. So the problem is that if you look at the meta-analysis, the Cochrane 2014 and 2016, either for acute cough or chronic cough, for acute cough, there are 10 randomized controlled trials in children with placebo, and there's poor reporting, there's no good evidence for effectiveness for anti-cough. If you look at chronic cough, there's not a single randomized controlled trial. So today, there's no evidence of these drugs are useful for children. Why I'm talking to you about this? Because they have to be aware, is that there is evidence for a link between full codeine exposure and neuromuscular anaphylaxis. And there are so many kids or adults or whatever that have been probably have already IgE induced due to the use in the past or infancy of this drug. And this is why I'm talking to you about this. And this is due to a shared recognition of substitute ammonium ions between the codeine and the myorelaxant. So if you have a patient who do anaphylaxis with myorelaxant, think about consumption of codeine before. And this is very important. In Norway, what they did in 2007, they retracted completely codeine, and what happens is that there's a drop in the incidence of anaphylaxis due to myorelaxant. And in fact, in Europe now, because we have less use of these codeine and codeine, we have a small incidence of anaphylaxis. In the apricot study, in all over 32,000 kids, we had only 3 anaphylaxis, and none under myorelaxant. Okay. So, to summarize, PRIMUM NON NOCERE Awareness is the greatest agent for change. So I think that succinylcholine, you may consider rocuronium now. Guidelines for emergency use for difficult areas, whatever, rocuronium. I still use succinylcholine in 2 conditions. Where laryngospasm that I cannot relieve with propofol and all the maneuvers, and on bowel obstruction. Otherwise, we got to rocuronium now for rapid sequence induction. Secondly, bupivacaine. You may have to switch to levobupivacaine. We don't have any more bupivacaine. We are using levobupivacaine now in infants and children to have a more range of safety. Paracetamol. I'm not saying you don't need to use it. I'm saying only question its usefulness. Is it useful when you give it like this? We have been in our hospital. We had also a complaint because one child had a toxicity, because in the night, the nurses can give paracetamol easily without calling you, whatever. So children can get toxic liver toxicity with paracetamol. And codeine, stop prescribing it and think about this mixed association with the anaphylaxis. I thank you for your attention.